There's something pretty wild about the state of artificial intelligence these days. We have algorithms that can crunch numbers, play chess, and beat any human at those types of narrow computational tasks. But at the same time, getting AI to do things that seem relatively simple for humans, like recognizing objects or understanding basic language, has been an immense challenge. This strange phenomenon is what's known as Moravec's paradox, named after the robotics pioneer Hans Moravec who pointed it out. It highlights this quirky disconnect where machines excel at the types of rigid, clearly defined tasks that are actually really difficult for humans, like playing chess at a world-class level. But then they struggle mightily with the sorts of cognitive skills that we biological organisms take completely for granted. Think about it. You can look around a room and instantly make sense of the world in a rich, multi-sensory way using vision, sound, and all your other senses working in harmony. Your brain is furiously processing quintillions of neural operations in parallel to perceive and comprehend your environment seemingly without effort. Yet replicating that ability in AI using traditional computer architectures has hit a brick wall. The reason this paradox exists really comes down to the way humans and machines approach intelligence from opposite directions. We evolved over millions of years to have general intelligence hardwired into our biological neural networks as a survival mechanism. Our cognition is grounded in real-world experiences gathered through our senses interacting with physical environments. Machines, on the other hand, are great at rapidly executing defined rules and optimizing narrow computational objectives. But they lack the embodied, multi-modal learning that allows humans to build rich conceptual models mirroring reality. They don't have years of diverse sensory experiences to draw from. So while playing chess is child's play for AI, grasping the depth and nuances of human experience may require an army of robotic scouts doing exactly that, amassing insights from sensing and manipulating the real world just like we do. Imagine legions of intelligent robots with cameras for eyes, microphones for ears, and even robotic hands to touch and interact with their environments. As these embodied AI agents explore, each accumulating unique data streams across different domains, they begin mapping the contours of our physical reality onto artificial neural networks. With enough data flowing in from diverse viewpoints, we may finally see conceptual models emerge that can reason like humans, understanding the world in a grounded, multisensory way. So in a sense, cracking Moravec's paradox could come down to sheer numbers. Not just more powerful hardware and more complex algorithms, but more embodied AI agents dispersed across environments, senses extended into every nook and cranny of existence. Like a planet's biosphere, a robotic collective working in parallel to distill insights from multimodal streams. Each agent serves as a diligent scout, their explorations flowing back to train AI architectures approximating general intelligence at scale. Just as the human mind develops understanding through childhood experiences, so too may artificial minds steeped in a critical mass of embodied sensing mature into broad, flexible reasoning abilities. Now figuring out how to engineer that robust transfer of learned representations into explicit, generalizable reasoning and causal comprehension, well, that's perhaps an even taller order. Because at the end of the day, an artificial general intelligence isn't worth much if it can't explain itself to humans in a natural, adaptive way. But that's a bridge to cross once we fully resolve the embodiment challenge. For now, the path ahead seems clear. The more diverse robotic data gatherers we deploy, senses extended far and wide, the closer we'll come to birthing truly intelligent machines that can make sense of the world just like we do. Maybe then Moravec's paradox will be relegated to a historical footnote, and we'll finally crack the code of general AI.